Welcome back. Now we have some experience doing some debug messages, and we're going to continue with some debug utilities in this video. I know that debug utilities are not the most exciting thing in game development, but they're important tools that you need to have under your belt before you can move on to the more exciting stuff. Now we've seen that we can print strings. I'm going to go ahead and move these nodes up so we have some more room. In fact, we don't need this actor begin overlap right now. I can remove that. I can simply delete it. And I'd like to print additional information to the screen. For one, I'd like to print this object's location in space. Now, we've seen that objects in our level have a location property. If we select one of those objects, such as our drone actor, we can take a look at the details panel and see under the transform section, it has a location which has 3 individual values, x, y, and z. We call these coordinates. We can access an actor's location by using a function in Blueprint. Now here in the event graph for BP drone, I'm going to right-click and type get actor location. And we have the option get actor location. This is a function, and the node has a yellow output pin. We see that it's called return value, and its type is vector. In Unreal Engine, a vector has 3 values, an x, y, and a z. Now notice that the pop-up says returns the location of the root component of this actor. So we treat actors as though they have their own locations, but really it's just the world space location of their root component. In our actor's case, it's our drone mesh that has a location. Now we've seen that we can drag an output pin from one node to the input pin in another node, and if those 2 pin data types are different, we can get a conversion node. Now this is only the case if the engine has a suitable conversion from one type to another. In this case, we're going to hook up the return value from getActorLocation to the inString input for printString, and if we release, we do get a conversion node. This converts from a vector to a string. So what does this vector look like in string form? Let's find out. Before we find out, I'm going to expand the dropdown for print string, and I'm going to change its duration so it sticks around longer than 2 seconds. I'm going to set it to 60 seconds so it doesn't go away for a full minute. And then I'm going to play test. I'm going to go back to the basic map so we can press play from here. And as soon as I press play, I see that debug message. So this is the string form for a vector. The conversion node gave us this nice set of values and even tells us which is the x, which is the y, and which is the z. Now, I'd like to select my BP drone actor so I can see its details panel, but I know that if I click in the viewport, I'm going to engage in the Pi session and I can control the default pawn. That's not what I want, so I'm going to hit Shift F1 to get my mouse cursor back, and then I'm going to detach. As soon as I do that, now I can click on that drone, and since I've selected it, my details panel has been populated with data, and I can compare the location XYZ with the debug message. Now it's almost been 60 seconds, so I expect this message to go away any second now. There it goes, it went away. So I'm just going to press stop and press play again and detach and select that drone pawn. Now I'm going to compare the XYZ values in the debug message with the XYZ values in the details panel for the drone that I have selected. The debug message says x equals 334.981. And in the details panel, the location says 334.9812. So there's a little bit more info there, but it is the correct value. The debug message says y equals 26.312, and the location y component is 26.312 plus some extra info. And the z in the debug message is 180, and the z in the details panel is 180. So these values are correct. So this tells us that we have a handy function, getActorLocation, that returns data in the form of a vector, and we can convert that to a string if we'd like to print that string. Now we can print additional information as well. For instance, each object in our world has a name, and that name is different than what we have in the outliner. If I select this BP drone, we see in the outliner that it's called BP drone here. But this is not the object's true internal name, not inside of the code. In fact, I can click on BP drone in the outliner, click on it again, and I can rename it if I want to. I can call it drone_1. Now I've renamed it here. But that's not going to change its internal name, but we can see what that internal name is in the code base by going back to our event graph, right-clicking, and using another handy function. And that function is called getObjectName. Let's get this function. We'll get the node. And this function has an output pin. We can hover over it. We see that its data type is string, and the pop-up says returns the actual object name. But notice that this function also takes an input. We have to pass something in to get that object's name. Well, I'd like to get the object name of the drone that we're in, the drone that's running this begin play script. And we can always get a reference to the self inside of an actor blueprint by right-clicking and typing in self, and we can choose get a reference to self. And we can hook that self up as the object for the getObjectName node. So rather than printing the actor location, I'm going to move these nodes away, and I'm going to hold Alt and click to break that pin. And instead, I'm going to drag in the return value from getObjectName to my in string. So I'm going to drag that in. No conversion node necessary because it's already of the string data type. So let's see what the object name is for this drone. I'm going to go back and press play, and we can see that it's BP drone_C_1. So it's basically the name of the blueprint class, except, well, there's some additional stuff appended to the end of the name. And that's typical. So the actual object name often has numbers and letters appended to the end of it. And that makes sense because there might be more than one of these drone pawns in the world. We may have two of them. In fact, I can drag in a second one here. And I can press play. And notice we have two debug messages because each of these instances of the BP drone exist in the world. And each of them have their own event begin play nodes executing at the beginning of the game. And as we can see, their names are not the same as the name in the outliner. In fact, we can detach and we can select one of them and see that this one is called BP drone and the other one, well, we renamed that to drone1. And those names are different than the debug messages we're printing from each of their blueprint scripts. So that's an important detail to be aware of. Now, before we wrap up this video, let's talk a little bit about this in string. Let's say we'd like to pass in multiple pieces of information. Perhaps we'd like to print the name and the location vector. Well, we could use two print string nodes, one after the other, if we wanted to do that. I could select the first print string, I can use Control-D to duplicate it, and in the first print string, I can pass in the object name, and in the second print string, I can pass in this vector converted to a string that we got from getActorLocation. Well, we could do that, and if we press play, well, now we have multiple messages here, 2 per drone actor, but it's not entirely clear which of these locations belongs to which of these names. The truth is that newer messages are pushed down and older messages appear on the top, which makes sense because the name is printed first and then the location. So first we had BP drone C1 printed and then its location, and then 2 and its location. But what if we want a single string that contains both pieces of information? Well, we can do that. So I'm going to take that second print string node and hit delete, and I'm going to break the pink pin from getObjectName, and we're going to construct a single string that has both pieces of information in it. And before we do that, notice that getActorLocation takes an input parameter as well, but notice that it has a text box with self. So this particular node defaults to the self if we don't pass something in for its input, whereas getObjectName does not have that feature. We have to pass something in to getObjectName, but if we don't pass something in to getActorLocation, then it defaults to the value of self. And in fact, we could plug in the value of self if we wanted to, and we would get the same exact result because it has the default value of self, but getObjectName does not. So anyway, let's say we'd like to construct a more complicated string. We can do that by right-clicking and searching for a function called append. Now there are multiple functions called append. We want the append designed for strings, and that would be right here under the string category. Notice that string is under the utilities category. So searching finds it right away, but we could simply right-click without searching and find that utilities category. Here it is, and expanding that and scrolling down until we find string. Here it is. And now we can see that append, and this is the version of append that we want. We can select that. Now this node is designed to append 2 or more strings together. For instance, if we hard-coded a string value in for A, such as drone name, colon, space, and then provided a value for the second string, string B, let's say we'd like to get the object name and pass that in, then the result of this will be both of these strings combined into one. Let's hook that up to inString and press play. And now we see drone name followed by the name of the drone. Now notice I had to put that space in there, otherwise there would not be a space. So it's up to me to put that space in that string. So that allows us to construct a more complicated string. But notice that append has an add pin node. If we click it, we now have another input called C. And we can pass a value in, or we can hard code one. I'm going to hard code space, location, colon, space. Remember, we always have to provide our own spaces when appending strings. And I'm going to press add pin again to get a fourth input called D. And for that one, I'm going to pass in the actor location string. Let's see what this looks like. Now we have an even longer string. It says drone name, followed by the actual object name, and then location, followed by that location vector converted to a string. So that's how we can append strings, and that can be useful when debugging as well. So we've now learned a couple important details when it comes to objects in our world. Actors have an internal object name, and that name is not necessarily the same as the name that they have in the outliner. In fact, we can rename those names in the outliner, and that doesn't change the object name from a code perspective. So we have a little bit more of a skill set when it comes to debugging information. We can print the actor location. We can print the object name. It's time to get a couple more utilities under our belt, and we'll continue with those in the next video. I'll see you soon.